All right, today, pairs of angles, section 1.4 here. For those of you who were in my math class last year and we started for the NISA test, this should all be a lot of review for you for the most part. Okay? So again, a lot of review for you. If you did not have my math class, hopefully it should be a review for you from like 7th, 8th grade math in a sense. You wouldn't have done a lot of this in Algebra 1, but the 8th grade NISA test has a lot of this information on it. So it should be some review for 8th graders, or freshmen right now. Vocabulary here. There are 5 of them. Just 5 today. Not too bad. Adjacent angles. Adjacent angles. 2 angles in the same plane with a common vertex and have a common side but no common interior points. Now when you read it that way, you're like, that's kind of tough. I don't know what that means. Really, adjacent angles are angles that are next to each other. They are immediately next to each other. Okay? So as I look here, if I draw angles, you know, angle 1 and angle 2 here. Those angles are adjacent. They are right next to each other. They share a line. It'll come up. They will share a line there. The line in the middle, they share that. They are right next to each other. Adjacent angles. Think about the term adjacent just like in real life. You have adjacent houses. If you are adjacent to somebody, you're next to somebody. Okay? A linear pair. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. Linear pair essentially comes from the root word line. So they are adjacent angles that make a line. All right, so if I had a line here with an angle, angles 1 and 2, they are a linear pair because they form that line right there. Okay, that's what makes them a linear pair. Complementary angles. Again, if you're in my class last year, we talked about this a lot, getting ready for NISA standards. But 2 angles who have a sum of 90 degrees. And all of these add up to get 90 degrees there. Okay, so again, 2 angles, or the sum of 2 angles, that add up to get 90 degrees. The biggest mistake students make with complementary and supplementary angles is they switch them around. Okay, so again, some way in your brain, find a way to get them to stick. One of the ways I tell students is think about the alphabet. You know, complementary C comes before supplementary S. 90 comes before 80. So complementary is 90. Supplementary is 180. Okay? Again, that's a way you can think about it. There you go. Thank you. 90 comes before 180. Supplementary angles then have a sum of 180. So again, 2 angles add up to get 180 degrees. Okay, the 2 angles, they would also form a line. Okay, they could also form a line. A linear pair is another name for supplementary angles. Okay, any type of angles that form a linear pair would be supplementary angles. And then lastly, we have vertical angles. The non-adjacent angles formed by 2 intersecting lines. Really, vertical angles are angles that are across from each other. So looking at angles that are directly across from each other. So if I draw 2 lines here, angles 1 and 2, they are across from each other. Okay? Something to note about vertical angles that will be important. Vertical angles are always congruent. Okay? Vertical angles are always congruent. Vertical angles always congruent. Yes, ma'am. But, supplementary and linear pair? Yeah. Yes. But you can also have supplementary angles that are not a linear pair. As in, they're on 2 different lines, but they're still supplementary, as in they would add to 180. Oh. If they were next to each other, they would form a linear pair, yes. Yeah. But they do not necessarily have to be a linear pair to be supplementary. Good question, though. Okay? All right, next slide here. Again, here's further examples of all those. Adjacent angles next to each other, 1 and 2. Linear pair, 3 and 4 are a linear pair. They are adjacent. They form the line going across. And then vertical angles, they are across from each other. So numbers 1, 2, and 3 here. I want to tell whether angle 7 and angle 8 are either adjacent, a linear pair, or not adjacent. So I want to classify those. Are they going to be adjacent, Are they adjacent, forming a linear pair? So we'll call that a linear pair. Or are they not adjacent? Looking at number 1 there. What do you think, Noah? What would number 1 be? I agree they are adjacent, but they also are a linear pair. Okay, so yeah, they are a linear pair. They form this line right there. Nice job. What about number 2? I have angles 7 and 8 again. What do you think, Gabe? Those are just adjacent. Nice job. Yeah, they are next to each other. They do not form a line, so that would be just adjacent. What about number 3? I have angles 7 and 8 again. What do you think, Bryce? Those are not adjacent. Yeah, they are kind of near each other. They do kind of share a vertex, but they are not directly next to each other. So they are not adjacent. Okay. Next one's here. Same problems here. Number 4, 5, and 6. Try those 3 on your own. 4, 5, and 6. Try those on your own. Number 4 here. So I'm looking at angles 5 and angles 4. So those angles right there. What is the best way to describe those, Jersey? They are adjacent. Nice job. What about now angles 1 and 4? So I'm looking at angle 1 here, and I'm looking at angle 4. What's going to be the best way to describe those, Ryan?
I said not adjacent.
Those are not adjacent. Nope. They are not right next to each other. And what about angles 2 and 3? So I look here, looking at angles 2 and 3. What do you think over there, Anna? Very good. They form a linear pair. All right, looking down below here, number 7. I want a pair of vertical angles. Who can remind me, what are vertical angles? Drew, what are vertical angles? Angles that are across from each other. If you look down there in that diagram, it might be tough to see with the symbols up there. I'll write them. What angles are directly across from each other? There are 2 answers here. What's one of them, Martina?
Angle 1 and 6.
Angle 1 and 6. Very good. Angles 1 and 6 are immediately across from each other. The other pair of vertical angles would be what, Camden? Very good. Angle 5 and angle 2. Those are directly across from each other as well. Nice work. What about linear pair? There's actually 5 linear pairs up there. There are 5 different sets of linear pairs. Okay? Who can give me one set of linear pairs? Kendrick, what do you got? Angle 3 and 4. Good work. Okay? Angle 3 and 4. That forms that line right there. What's another example of a linear pair, Camden?
5 and 1.
Angle 5 and angle 1. Very good. So I look here. There's a line. What's another linear pair that I would have? Austin?
1 and 2.
Angle 1 and angle 2. There's a line. Give me another one, Catherine. Angle 5 and angle 6. Nice work. There's a linear pair. And the last linear pair. Does anybody have it? Tom?
6 and 2.
Very good. This one right there, angle 6 and angle... Yeah, we were doing square roots in algebra 2. Angle 6 and... Oh gosh, did it again. Angle 2. There we go. Last one. Last one here, number 9. An angle adjacent to angle 4. There's only one answer here. What's the only angle adjacent to angle 4, Mr. Goldap?
3.
Angle 3. Good work. So that's the way to describe pairs of angles. Next, we're going to talk about complementary and supplementary angles. Complementary angles add up to what again, Jack? 90. Okay. Supplementary angles add up to what, Johnny? 180. Okay, so that's the difference between the two. As I look down at the bottom, I want to tell whether the pair of angles are either complementary, supplementary, or neither. So as I look here, I have 45 and 45. Are those going to be complementary, supplementary, or neither? What do you think, Hannah? I have two 45-degree angles. They would add up to get us 90, which is a complementary pair. Nice job. Run out of room as I write. All right? And the next one here. I want these two angles. They're both 110 degrees. Okay? Would that be complementary, supplementary, or neither? What are you thinking, Jessica? That's neither. Yeah, if you add those two angles up, they are actually 220 degrees. All right? Try these four. I want you to find the measure of each of the following angles. Okay, so complementary adds up to what again, Jersey? Complementary? 90. Supplementary is 180. And that goes with S. Okay. And then we have the same for 14 and 15. And that's going to go with R. All right, let's look at this here. Number 12. What's the answer to number 12? The complement of angle S. What do you got, Ryan? 34 degrees is correct. Nice job. Complement means, again, they add up to 90. What's the supplement of angle S? What do you say, Keegan? It was 56. Huh? So supplement has to add up to 180. So 56 plus what would get me to 180?
They work this harder in weights.
124. Nice job. That would be the supplement. All right. Number 14. The complement of angle R. Caitlin, what's the complement? 68 degrees. Good work. And the supplement of that would be what, Martina? 158 degrees. Good work. Complement supplements, 90, 180. Remember that. Last one here. Last one, I promise. Angle LMN and angle UVW are complementary. They add up to 90 degrees. Good job, Camden. It says find the measure of each angle if LMN is 3x plus 5 and UVW is 2x. What do I know about those two expressions? They're going to add up to what, Bryce? 90. So I take 3x plus 5 plus 2x and set that equal to what, Caitlin?
What? Oh, I'm not.
Thank you, Nick. I'm going to set that equal to 90. Solve that from there. All right, let's go through the problem here. When you work this out, what do you get x to equal, Trevor? Yeah, x equals 17. You work it out. From here, then, I need to go back and find the measure. So I plug this in for x there and in for x there. And I get the angles to be what, Mr. Goldap?
56 and 34.
Very good. 56 and 34 degrees, which are complementary angles. Nice work. Here is the assignment.